Yeah, so I have a screen capture now. We can see here, so I'm going to click on copy, and now I'm just going to open up a PowerPoint presentation, and I'm simply going to paste this in. So now I have this nice image of this polytope. Maybe make it a little larger, and now I can start doing things with this. Okay, so the first thing that I would like you to do is I would like you to label all of the polytopes, or the corner of the polytope, and this seems to be a good color. We can just use black, and then it's kind of this kind of light greenish blue color. That's a good color we can use. So I'm just going to make a bunch of copies, move these around, put them on the corner points. So if you hit Control and then your arrow keys, you can adjust these to wherever they need to be. So I would like you to go in and identify as many corner points as you can. So here's a corner point somewhere. Here's a corner point. So far we have how many? 5. And then we'll do, here's a 6th one. And how many corner points at this point? I have 8 corner points. Okay. Now what I want you to do is from the second part of the problem, I want you to show the simplex method, record the values of x1, x2, and x3 for each iteration. So for the first iteration, I want you to start out with values of, say, 0, 0, 0. I want this to be your initial starting point. Make the font for this a size 12 font, say Times New Roman. So the first point is 0, 0, 0. So maybe you can draw an arrow identifying that this is the first point. And I'll put an arrow on the end of it. Maybe I can, something like that. Now for the second point, let's suppose the second point in the simplex method had been this point right here, which is this is x is going to be positive, z is 0, and y is 0. So let's see what point this would be. I have to find this point. So that particular point, it's going to be where z and y are both 0. So let's see what point. So it's going to be where plane B, Y, and Z intersect. So this is going to be point 2, 0, 0. So this is point 2, 0, 0 right here. Now, I'm just assuming that this is, say, a solution you're going to get from the simplex method. It could be this point, or it could be this point. It could be any one of these 8 points. And I notice I forgot a point here, so I'll move a point down. But let's just assume that this was the first iteration result. So I'm going to draw an arrow up to maybe this point right there. Okay. Now, what I would like you to do is I would like you to draw an arrow connecting these 2 points. So I'm going to go from the origin to this point, and if you hit the Alt button, it allows you to kind of fine-tune this arrow. So I release it. We notice that this arrow is black, so we can't really see it. There's not much of a contrast. So I'm going to go in and change the color, make the weight say 1.5, make the color a bright red, make the arrow size maybe a little larger, so then I preview it. I can see that I'm showing that the point we moved from 0, 0, 0 to 2, 0, 0. Now with the second iteration, let's suppose that you move from this point to this point. Remember, hit the Alt button and it allows you to fine-tune this adjustment. Right mouse click, go to Format Auto Shape. Let's make the arrow size large. Red, make this a I'm going to click on Default for New Objects, preview it, and then let's suppose that the last iteration said we're going to go from this point here to this point here. So we can see how we have kind of walked around this particular polytope, and you'll be able to see that from the simplex. So you can see you started at point 0, 0, 0, went to 2, 0, 0, went to this point, and then finally you stopped at this particular point. Now what you can do is you can simply highlight all of these and go to Group. So you can group these objects. You can copy this, and then I'm going to open up the software called GIMP. And at this point you can paste this as an image, and then you can paste it into a Word document. If you paste it directly from PowerPoint, it pastes it as a PowerPoint image, and it doesn't allow you to scale it all that well because of the it's an actual object instead of an image. So I can simply go to Edit, Paste As, New Image, and you can see that I have pasted this into GIMP. So now I can save this. Save as. I'm simply going to save it on my desktop, and I'll just call it say polytope.jpg. And I would like you to include this. Make sure you save it as 100% quality. I would like you to include this as one of your files that you send to me. So you can see how you can use the Excel template to find the 8 basic feasible solutions. Use GraphCalc. I want you to plot the 3 constraints in the objective function. So to bring up the objective function, all you have to do is go to Equations and make sure the objective function is this nice blue color. And I would like you to include the objective function as your image. I didn't because I was just demonstrating how to put these points and draw arrows, but make sure you include the objective function. You can see that the objective function touches the polytope at this one point right here. So what I want you to get out of this is I want you to see how the simplex method relates to these basic feasible solutions. So I want you to observe the relationship between the values of the decision variables x1, x2, x3, and for each iteration, and the basic feasible solutions. So this is the instructions for completing problem 3 of exam 1.